Thanks, Amila. It's a pleasure to be here. Okay, I'll wait for slides to come up. Okay, while we wait, I haven't read the second book, no one said. So, okay, let me start with, when we see some code we don't like, we used to have this expression that we say. And there's a story behind it. Let me start with that. So a few years back, I think this 2012, etc., somebody broke the build, which make Aziz very, very unhappy. And I think you, okay. So, and he sent a certain 3-letter word, which led to a lot of discussion. And eventually, Sanjeev suggested what he meant was, why the flowers? And for some time, we were using this term. It's used less now, but maybe we can restart. Okay. So when you find that code, I mean, this we all do. Like we look at it and then we try to dig in. And there are some times the developer who wrote the code had screwed up. But not all the time. Sometime when we go and look into the details, and when we start understanding, we figure out that actually we can't blame the developer. So when that happens, that's a sign that there's something wrong with the architecture. Right? So let me take an example. Now, you can screw up good architecture with bad code, but it's very hard to fix bad architecture with good code. Right? Let me take an example. So this is something we found about, I think, early part of 2024. But so basically, there was this setup where when we call the get component, it ended up doing about 9 API calls. And each of them, again, go and do 3-4 more calls. Right? This is just an example. There are a lot of these. Now, reason this happens is that now if you are one of the developers who write in code like get component, there are certain information you need. You need it, right? To get it, you have to call these things. So, if you are the developer who write in that code, there's no way out of it. And this happens, in this specific case, this happens because of not doing the domain decomposition correctly. But this is something that can very easily happen with microservices. Right? So, even good ideas sometimes hurt. So today's talk, I will talk about how the quality of architecture, good architecture, can help you write good code or simplify the code. And of course, the whole point of architecture is to make the code easy. And we'll talk about how to do good architecture on the way. So let me go to one more story. So I talked to somebody a few years back, He was from earlier generation from us. He was building a house. Then he had decided to go and talk to a structural engineer. This years back, this not the time, at least in Sri Lanka, that you wouldn't go to a structural engineer at that time. I mean, if you do a big building, yes, but not for your house, right? So when he went to the structural engineer, he have looked at it, looked at the design, and he asked to remove about half of the structures, right? And then the person told the story, he said he didn't. Right? Because he was expecting the structural engineer to add more strength. But the structural engineer took half of it away. So basically said, take it away. And this actually kind of puzzles me. And then it kind of makes sense, right? Because otherwise, all the houses will fall off. All other houses without a structural engineer would fall off. The reason the engineer that who understands the theory and how it works, what he does is he takes away the unnecessary stuff. Right? So the good architecture is like an arch. You know that Romans created it, right? Roman arch. It holds on just with the bricks. Of course, you can do that with concrete. It is as or even more stronger, but useless and very expensive and cumbersome. Right? So the good architecture in software is also similar because the good architecture would let you solve the problem with much less code. So we have talked a lot about good architecture. To put it very simply, good architecture would try to take the problem and break it to small parts. Each part stands alone as much as possible. You will put the related things together, right? And the most used components would be more stable. Basically, that would reduce the duplication. It will try to allow for future requirements. Usually, way to do that is to make the state available easily because then easy to extend, etc. It is easy to understand, easy to explain, and will provide the language to clearly communicate what's going on. Right? So, and of course, it should minimize the accidental complexity. Complexity that is not inherent to the problem, that is added by your stuff. And if you look at these, each of those, they very naturally would reduce the complexity of code by reducing the duplication, giving you that language to talk about, right? Make it easy to understand. It may not necessarily simplify the code at this moment, but given long run, it will. So I will talk about three things I believe would help us build good architectures. The first one is to approach the problem from the perspective of the user. When we, as architects, when we try to build design, we know a lot more about what's already in the system, too much. And it is very easy for us to build a design that make it very easy for us to solve that problem, right? Not exactly what the user wants, right? So we look from inside out, right? And this is, in my opinion, this is the most common mistake experienced architects make. But to see how, let me take an example to tell how destructive this can be. So there's this, a few years back, there was an effort called Code for America. They were trying to build this system, series of systems, to basically do e-government for US. So I saw I'll make these two observations, then we will connect, right? The first thing is that when we open this system up, a lot of people were not joining, right? So this social security kind of system. So you want people to join. But people are not joining. Some percentage joined, but not enough. Observation 1. The observation 2, when they watch what happened with the people in, you see that on the 31st or end of the month, midnight, people are using this system heavily. What this system did was they gave, it's a social security thing, everybody get a card, you can go and buy stuff. Now, who would go and buy stuff at midnight? At end of the month. People who are hungry, right? Otherwise, why would you go in midnight, end of the month? Because this is the day that your money would recharge. Right? Now think about it. People who are going hungry, even they couldn't finish the registration. Now it tells you how much bigger a role the user experience plays in a system. Right? Now, the most unfortunate thing is it's very unlikely somebody actively tried to sabotage this or build a system that's very hard to register. It's just that the people didn't worry about it hard enough. It suddenly changed the user experience so much that it's almost impossible to use. So this is very, very important. So to get it right, you really need to look from the end user's perspective. So I'll take a quick example. Think of the fresh fruit delivery service online, right? Now let us assume that the delivery, now your fruits are in different places, you can only deliver within certain area. Now if the customer come and search, if you did not think from the user's perspective, what you would do is you will show the results, but when you try to add it to your cart, you would say, you can't have that. Actually, we see, not in exact the food delivery one, but this is a common thing you would see. I mean, this is a common thing you can see at different cases. You go and search, you can see the thing, but when you go in, say it's not there, you can't have it, or something like that. Now, if you don't consider this and build the system, and fixing that later is very hard. Right? But if you look from the end user's perspective, and you say that you must only show the things to the user that he can buy, then you can solve that. The way to solve that, sorry, I didn't tell why it is complicated, because I am at this location, now I am searching, and before showing what I can see, I have to the system has to calculate all the combination of items against my location to decide which one to show, which is very expensive. But if you say, okay, I have to solve this problem and look at it, you would see that I can define cells and pre-calculate these values for each cell. And when person comes, you say, okay, he's in this cell, show these results. Search within that. The important thing is that you will only see the problem if you look for a solution. If you look from the end user's perspective, and if you say, this is the experience I must have, now let me find out a way to solve this, there's a good chance you will see the problem. Versus if you are looking from internally and say, let's do something easy, you won't find the solution. That's the first one. A second one, my life made much easier by Sanjay in the morning because I was thinking about how to explain this. So the orthogonal design. The first thing is that when we take a feature, right? When we take a feature and when we implement, first thing is that never implement the exact requirement you are asked to do. You need to ask, what are the other requirements around it? Right? So basically ask, okay, if he is asking for that, what are the other things he might want to do close to that? This is what Sanjeev meant by think from first principles and try to find what he and or she and others related to that, what are the other requirements. Identify that. Go back, figure out a bigger problem you are solving. Then find out the orthogonal aspects. And when you solve, I'm not explaining that part again because Sanjay went through that in a lot of detail, right? Take the orthogonal aspects and break it, and then all you have to do is solve each part. And if you are writing code, basically you try to do each part, and by combination you can solve ideally all the problems. So now, as before, let me jump into the architecture side and give an example. So when Sydney Opera House was built, all its domes were actually designed such a way that it cut from a single sphere. That makes a huge difference. Because now it is very, very easy to explain the requirements. It is very much more simpler to do the construction, and you can build different parts separately, bring it together, and you know it will work. Right? So having that underlying model suddenly simplify. Actually, at one point they said they couldn't build it, and then the architect came up with this. So it is by orthogonal design, but that's what we are trying to do. Sometimes, yes, sometimes the underlying thing you can go even to the mathematics, but you can often describe it's just the explanation of different things and how they work together give you the story. To give you an example, I'll take Kubernetes as an example. Now, Kubernetes has these different things, controllers, CRDs, etc. So these are the orthogonal aspects, right? Now, combining those, you can build pretty much any system you want, right? And we are building those, right? that figuring out those aspects took some work, right? So the saying that, okay, what kind of problem I'm solving? Okay, solve that problem, I want these things. I want the kinds, and then I want the controllers, and okay, you want to extend the client. So that kind of story, they figure that out very often with some iteration, but once it is done, it covers a huge amount of the problem. So this is the number 2. Okay. The next one, third one, and the last thing. Okay, on one end, this happened in architecture reviews. We asked you to do orthogonal design. Also, we asked you to do crawl, walk, run. So which one is more important? Right? Because the crawl, walk, run means only do what is necessary for at this point. Right? But orthogonal design means go deep, understand, and solve it. This is one of the main challenges of software architecture, balancing these two. So my answer to this problem is design important things that are hard to change in detail. And rest you can figure out. Okay, so I'll try to break that down. Okay. What are things that are hard to change? APIs. Almost very, very hard to change. Right? Even with a rewrite, you can't fix it if you mess it up. Not can't, very hard, right? It takes years and years. If you have customers using that API, even if you put a new version, there'll be a lot of people using the older ones. Database. So these two are the harder ones, etc. These are different levels. So these ones, you need to think it through. Fact that you thought about it doesn't mean you have to jump and implement it fully, right? So the goal is to have a design that does not put you into a dead end, right? Because the rest you will change. So basically what that means is that ask the question, is it important? Is it hard to change? What level does it matter? Scale, okay? Scale, hard to change, fine, but how much scale you want? Level, right? And then design. But the truth is, at each level, you need a lot of judgment, right? Yes, I'm kind of trying to give you a little bit of formula on this, but in reality, it comes down to judgment. Breaking down a bit more, but it is the judgment. And that's what we do. That's what we paid for, right? To make that judgment, to take these different things and to understand the pros and cons and to make a decision. I really love this quote. In my opinion, if you are doing any design, any architecture, if you think about it deeply, you will have several conflicting things. You will see 2, 3 things. If you improve this, this will go down. If you improve this will go down. And then you have to balance and find the right answer. Almost every architecture has that. If you go deep enough, you will see that, right? And it's not simple. That's why you need to kind of have two different ideas, which is that orthogonal design and crawl, walk, and run. And to acknowledge both are important and think about both, but not to freeze. Okay, so let's finish. So these are different signs when you go into the code that suggest that architecture can be improved, right? So one final thing to really understand about the design is that we have to disconnect as a person from the design. I have been doing designs for about 20 years. Most designs, half of the time you are gritting your teeth because you don't agree. That's the definition of that job, right? But most systems, when you go back and when you look back, the final design is better than what you could have done. Aggregate, right? So maybe some parts, if you win, it could have been better, but then there are everybody has that. Everybody has few things that may have made things better, but couldn't make it true. But on aggregate, it end up better. When you design, you don't know the future, you can't see all the angles. There's no shame in it, right? But as a developer, when you implement it, you will see all the angles. At least if you think deeply, you will see all the angles. And when you see that, come and complain. And I'll promise we will listen. The truth is now, that component problem I show, we were trying to fix it. We will fix it with V3. Some of these changes take years to fix, right? So, but still, I think it is very important to see that there's this problem and discuss it. Some we can fix, some we accept. We will fix when we can. So, the final thing is that, So, I said that sometime when you see not so good code and look at it, yes, sometimes developers to blame, sometimes it's not. And if you are writing the code, you will feel that. If you are thoughtfully writing the code and if the architecture has a problem, you will feel that. When that happens, come and talk to few people, right? And some of them we'll fix, sometimes we won't agree, right? But I think it's that back and forth between the code and architecture and trying to improve will get us to the best version. Thanks very much. And I can take any questions. 1 minute to go. It's very important for, bread can be fresh, right? Okay, it's not produced, fine. Okay, got me. I think that's a good note for me to exit the stage. Thanks.